Biogas plants handle combustible gas under pressure, moving equipment, and complex process systems. ATEX safety keeps these hazards controlled. Methane can form an explosive atmosphere when it mixes with oxygen in the right concentration. Biogas commonly contains 50 to 70% methane and substantial carbon dioxide. Hydrogen sulfide and other contaminants create additional health and process risks. Methane's explosive range in air is approximately 5 to 15%. An explosion requires fuel, oxygen, and an ignition source. Removing any one side of this triangle can prevent the event. ATEX requirements control explosive atmospheres, ignition sources, and equipment used in the area. ATEX refers to European requirements for equipment and workplaces where explosive atmospheres may occur. These requirements apply to digesters, gas holders, treatment systems, compressors, upgrading skids, and gas delivery equipment. The first question is whether an explosive atmosphere can occur at the equipment location. If yes, the area must be assessed, classified, and controlled using approved documentation. ATEX zoning describes how often an explosive gas atmosphere may be present. Zone 0 is where an explosive atmosphere is present continuously, for long periods, or frequently. Zone 1 is where an explosive atmosphere is likely during normal operation. Zone 2 is where an explosive atmosphere is unlikely and short-lived if it occurs. Zone boundaries must come from approved classification drawings, PNIDs, procedures, and risk assessments. At feedstock reception, inspect receiving pits, feed pumps, tank vents, and gas connections. Around digesters, hazards may involve gas spaces, relief systems, sampling points, mixers, and pumps. Gas holders require especially careful control of membranes, valves, vents, and connected pipework. Gas treatment areas may include hydrogen sulfide removal, chillers, condensate drums, and activated carbon units. Upgrading systems may contain feed compressors, membrane trains, dryers, analyzers, valves, and delivery systems. The same equipment may have different requirements depending on zone, gas composition, pressure, and ventilation. ATEX markings provide essential information about equipment protection. For example, 2G, XDB, IIB, T4, GB. The marking identifies surface industry equipment, gas protection, flame-proof protection, gas group, temperature class, and protection level. The complete marking must match the hazardous area, gas group, temperature class, and application. Typical equipment includes motors, terminal boxes, solenoid valves, sensors, transmitters, pumps, mixers, and compressors. Instrumentation may include pressure transmitters, level devices, gas analyzers, and flowmeters. A small cable gland, junction box, sensor, or replacement component can affect the entire installation. Never install a substitute part simply because it fits mechanically or appears similar. Digesters combine methane, pressure changes, relief devices, moving equipment, heat, and possible mechanical sparks. Before maintenance, confirm equipment status, energy isolation, gas conditions, and permit requirements. Pressure relief devices must never be blocked, bypassed, or altered without formal authorization. Blowers and compressors face high temperature, seal failure, bearing overheating, pressure changes, and static electricity. Important safeguards include temperature monitoring, gas detection, automatic shutdowns, earthing, and preventative maintenance. Membrane upgrading systems operate with pressurized gas. A failed fitting, valve, seal, or instrument can release methane and create a hazardous cloud. Inspect connections, monitor pressure, verify alarms, and follow approved startup and shutdown sequences. Carbon dioxide liquefaction adds pressure and low-temperature hazards. Operate compressors, refrigeration units, purification equipment, and storage tanks within design limits. During maintenance, use isolation, depressurization, gas testing, and suitable protective measures. Inspection is a direct control against ignition and loss of containment. Confirm that certification plates are legible and approved, cable glands are correctly installed. Verify earthing and bonding, and look for corrosion, damaged seals, missing bolts, cracks, and overheating. Confirm temperature limits and ensure that no unauthorized modification has been made. Damaged flame paths, incorrect fasteners, uncertified parts, and temporary repairs can compromise protection. If a defect is found, make the equipment safe, report it, and follow the approved repair process. Fixed gas detectors may be installed near compressor rooms, upgrading skids, gas holders, and valve stations. Detector location, calibration, alarm set points, ventilation, and shutdown actions must follow the approved design. Some facilities use staged methane alarms at 20, 40, and 60% of the lower explosive limit. These values are training examples, not universal settings. Follow the plant's approved alarm philosophy. At higher alarm levels, the process may require controlled shutdown, isolation, evacuation, and emergency response. Never silence or reset an alarm without understanding the cause. Hot work includes welding, grinding, cutting, and soldering on or near biogas equipment. Before hot work, gas test the area, isolate equipment, approve the permit, and assign a fire watch. Stop if gas is detected, ventilation fails, isolation is uncertain, or the task changes. HAZOP studies examine deviations such as no flow, reverse flow, high pressure, and high temperature. The resulting safeguards may include gas detection, shutdown functions, interlocks, venting, and pressure protection. If a gas leak is suspected, stop work and avoid creating an ignition source. Move away, warn others, notify the control room, and follow the site emergency plan. Keep people away until authorized personnel assess and declare the area safe. After an explosion or major incident, account for personnel, isolate safely, contact emergency services, and preserve evidence. What is the primary explosion risk in most biogas plants? Methane. Which zone describes an explosive atmosphere that is continuously present or present for long periods? Zone 0. Before opening an ATEX junction box, confirm isolation, area safety, and permit authorization. Motors, compressors, gas detectors, and many other hazardous area devices may require ATEX certification. For the practical exercise, review and approve biogas drawings and identify zones, equipment, ignition sources, and safeguards. ATEX compliance is a system of decisions made during selection, operation, maintenance, and change management. Know the zone, verify the equipment, control the energy, test the atmosphere, follow the permit. In a biogas facility, disciplined attention protects the process, the equipment, and everyone working nearby. Thank you for your attention. If you require technical assistance with ATEX zoning, please do not hesitate to contact us. Contact Frederic Salimi. Email symboladmin@epc365.com. Globe with Meridians https://iatech365.com. We look forward to supporting your ATEX zoning studies for biogas installations, helping you identify hazardous areas,
ensure regulatory compliance, and reduce the risk of explosion within your facility. Have a nice day.